Alright guys, so hey, we're about to start Learning Target 7C. So first off, you need to know what Learning Target 7C is. It's titled Understanding Trigonometric Functions. It's kind of a general title. Understanding Trigonometric Functions. So if we look at let's look at the words there and what's familiar. Trigonometric, okay? So for the most part, we're talking about sine, we're talking about cosine, we're talking about tangent. Our big emphasis will be on sine and cosine. Now, you guys have seen sine and cosine really as tools used to solve problems, whether you're doing right triangle trig and SOHCAHTOA, or you're doing some non-right triangle trig and you're doing like law of sines or law of cosines. You're finding missing sides, you're finding missing angles. So that's where we've seen trigonometry thus far. But as far as looking at sine as an actual function, having inputs and outputs, we haven't done that yet. So target 7C is about those functions, the sine function, the cosine function. We certainly have a basic understanding at this point, of the sine and cosine function, and that was built from the unit circle. Okay, so if you think about sine, right now you're thinking, okay, that is the y coordinate on the unit circle, and cosine was the x as x coordinate unit circle. So you could build a graph of the sine function and you could build a graph of the cosine function. Let's do that real quick. Okay, let's say you have your input is x, and we'll have x in terms of let's say it was in terms of degrees, and let's say our output, let's deal with the sine function, sine of x. Right, functions have inputs and outputs. So, when x is 0, well, what's the sign of 0? You'd say, okay, the y value, the y coordinate at 0 is 0. And you could go up to, let's say, like, I know you could go in between, you could do like a 15 degrees. I don't know the exact value of sine of 15, what that height is there, but I know, let's see, 30 degrees, I know the sine is 1/2. I know 45 degrees, the sine is root 2 over 2. 60 degrees, it's root 3 over 2. 90 degrees, it's 1. So I could build a table of values that help me graph the sine function. Make some more room here. Now, how far would you go with your x values? Okay, you could go 90, then you could go what? You could go 120. Let's see, sine, that's root 3 over 2. You go 135. That's root 2 over 2. You could just keep on going this list, keep on going. You might get all the way up to x equals, let's make this smaller here. You could keep that list on going, right? You could get up to all the way x equals 360 degrees. The sine of 360 is 0. You could go to like, 400 and, I don't know, 450 degrees. So let's see, 450 degrees. Okay, well, I got my unit circle. I go once around is 360. 450 is 90 more than 360. Yes. So 450, that's up here. The y coordinate right there is 1. So what I started with a couple minutes ago was sine is actually a function. Okay, it has inputs and it has outputs. Okay, I've set it up right now. I said we're in degree mode. The inputs are degrees and the outputs are the y values along that unit circle. So you could actually graph that. And what's cool, if you remember back to the iPad app I had where I dragged that dot around the circle, if you think about what those values for sine were doing, they go up to 1, they go down to 0, they go down to -1, they go back to 0. So you end up with, if you graph the sine function, you end up with a graph that looks like this. That's one full period of that. So this is 2 pi radians, or it's 360 degrees, and half of it, is at pi radians, 180 degrees. But it's this cool wave-like function. Sine it goes up and it goes down, and they're really neat functions. Sine and cosine are, and even tangent. But we'll look at sine and cosine. They're neat functions because a lot of the stuff we try to model in the real world, it goes up and down. If you think about sound waves, if you think about the tide, so different things need different types of models, and things that are periodic in nature, they just, kind of thinking about this wave, and they go up and they go down and they go up and they go down. We need functions that go up and down so we can model these happenings, these phenomena. So a linear function isn't good for tracking tracking tide, right? The ocean's tides, because a linear function either keeps going up or keeps going down. It never has that turnaround point. So sine and cosine, they're useful tools in geometry. They're functions too, and their graphs are quite helpful, and that's what we're going to study in this learning target. Now, if you remember graphing functions previously, it's not like we just graphed x squared, right? Well, x squared is kind of a cool model. It looks like this. That's x squared. But it's not often that we had things that were modeled just by x squared. A lot of times what we'd have to do is we'd have to transform the graph of x squared. You'd have to shift it left, you'd have to shift it right, you'd have to vertically stretch it, you'd have to horizontally compress it. You'd have to slide it down 10 units. So we're going to do the same thing with your trigonometric functions. So a little quick review here before we start playing with the sine and cosine functions is, let's say you have your f of x plus 1. Okay, so let's say, how does that affect x squared? So f of x plus 1 with x squared would be x plus 1 squared. Well, what did that do to the graph? If you remember, that was left 1 unit. What about f of x plus 9? Well, that would be x squared plus 9. That was up 9 units. What about 6 times f of x? So we're reviewing transformations. That was 6 times x squared. That was a v stretch by factor of 6. So vertically stretched our graph. What about f of 2x? Okay, that would be 2x squared. Now that wasn't a horizontal stretch, that was a horizontal compression by factor of 2. So all of the x's got divided by 2. Okay? So we're going to do all of that stuff to the sine function and the cosine function. You're going to use the context of the problem to determine how you need to stretch the graph or slide the graph. So this next learning target, 7C, is about sine and cosine as functions. How can we use those functions to model things that happen in the real world? And we'll use transformations to help us fit those basic sine and cosine functions to real world problems. So that's what's coming up in 7C. Thanks a bunch for taking time to check out the introductory video, and we will get started with this tomorrow. I hope you guys have a great evening.